Using the laws of indices, solve the following equations. So solve means find x, get x on its own, and our laws of indices are in our formula book, so use them to help you. So question 1, 2 to the power of x equals 2 to the power of 7 root 2. Now notice that these are stuck together, which means they're multiplied together. So we want to rewrite everything as a base of 2, so 2 to the power of something. So it's only this square root of 2 that we need to change. So we bring down the 2 to the power of x that equals the 2 to the power of 7. Notice I have brackets now around the 2 to the power of 7. And the square root of 2 is 2 to the power of a half. The square root of anything is that number raised to the power of a half. And again, notice I have brackets here to indicate that we're multiplying them. So we're going to multiply 2 to the power of 7 by 2 to the power of a half. And ultimately we just want 2 to the power of something. Because if we have 2 to the power of something on the left and 2 to the power of something on the right, we can cancel out the 2's, we can cancel out the bases and solve for x. So multiplying powers with the same base, we're going to add the powers. So we're going to get 2 to the power of 7 plus a half. So we have 2 to the power of x equals 2 to the power of 7 plus a half. And 7 plus a half gives us 15 over 2. So we have 2 to the power of x equals 2 to the power of 15 over 2. Now we can cancel the bases. Now we can cancel out the 2's. And cancelling out the bases, we're left with x is equal to 15 over 2. And you can check your answer by substituting 15 over 2 in place of that x. So 2 to the power of 15 over 2, if you put that into your calculator, you will get 181.019336. And if you put 2 to the power of 7 root 2 into your calculator, you will get the same. And that's how you know that x is definitely equal to 15 over 2. Part 2. 2 to the power of x equals 2 to the power of 7 over 4. So we're going to write every term as a base of 2. So the only thing we need to change is the 4. So we're going to rewrite 4 as 2 to the power of 2. So we have 2 to the power of x equals 2 to the power of 7 divided by 2 to the power of 2. So ultimately we want 2 to the power of something on the left of the equal sign and 2 to the power of something on the right of the equal sign. So we need to simplify here. So dividing powers with the same base, we're going to subtract the powers. So we're going to have 2 to the power of 7 minus 2. And 2 to the power of 7 minus 2 gives us 2 to the power of 5. So we have 2 to the power of x equals 2 to the power of 5. The bases now match, so we can cancel out the bases. And we're left with x is equal to 5. Part 3. 5 to the power of x equals 125 over the square root of 5. So we want to write every term as a base of 5. So we want to rewrite 125 as a base of 5 and the square root of 5 as a base of 5. So 5 to the power of x just stays the same. 125 we rewrite as 5 to the power of 3, and the square root of 5 we rewrite as 5 to the power of a half. Next, we're dividing powers with the same base, so we subtract the powers. So we're going to have 5 to the power of 3 minus a half. And 5 to the power of 3 minus a half gives us 5 to the power of 5 over 2. Now we have the bases the same, so we can cancel out the 5's, we can cancel the bases. And we're left with x is equal to 5 over 2. Part 4. 3 to the power of x plus 1 is equal to 9 over the square root of 3. So we're going to write every term as a base of 3. So 9 we're going to rewrite as a base of 3, and the square root of 3 we're going to rewrite as a base of 3, because this already has a base of 3. So we bring down the 3 to the power of x plus 1. 9 we rewrite as 3 squared, and the square root of 3 we rewrite as 3 to the power of a half. Next, we're dividing powers with the same base, so we subtract the powers. So we're going to have 3 squared, so 3 to the power of 2 minus a half. And 3 to the power of 2 minus a half gives us 3 to the power of 3 over 2. Now we can cancel the bases on the left and the right, so we can cancel out the 3's. And we're left with x plus 1 is equal to 3 over 2. So we have x plus 1 is equal to 3 over 2. Now we're going to bring the plus 1 over the equal sign. It'll become minus 1. So x is equal to 3 over 2 minus 1. So x is equal to a half. Question 5. Solve. 10 to the power of x minus 3 equals the square root of 10 over 100. We're going to write every term as a base of 10. So 10 to the power of x minus 3 already has a base of 10, so we just write that down. The square root of 10 we rewrite as 10 to the power of a half. And 100 we rewrite as 10 squared. Next, we're dividing powers with the same base, so we subtract the powers. So we're going to have 10 to the power of a half minus 2. And 10 to the power of a half minus 2 gives us 10 to the power of minus 3 over 2. Now we have 10 to the power of something on the left, 10 to the power of something on the right, so we can cancel out the bases, cancel out the tens. And we're left with x minus 3 is equal to minus 3 over 2. So we have x minus 3 equals minus 3 over 2. We want to solve for x, get x on its own. So we take the minus 3 over the equal sign, it becomes plus 3. So x is now equal to minus 3 over 2 plus 3, which gives us 3 over 2. So x is equal to 3 over 2.